Hi, welcome to question 2 of the Leave Cert Ordinary Level 2025 Paper 1. So if you want to copy these notes, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. So part A, here's question 2, sorry, is a complex number question. These can be pretty straightforward, although can be tricky. This part A, part 1, I don't know what the marks are. The marking scheme is not out yet, but Z1, you're given the complex number, it's -1 plus 2i. Z2 is 2 plus 3i, and Z3 is 4 minus I. Now, complex numbers are kind of strange, okay, in a way, and just it's very different. But this first number is the real part. The second thing is the imaginary part, and that's what makes up a complex number. And you can kind of correspond that to an XY diagram, which is like the first letter number is the X, the second thing is the Y. Now, in a complex number graph, it's called an Aragon diagram. And the question here states the complex number Z1 is shown on the Aragon diagram below, and then says plot and label. So it's very important to label Z2 and Z3 on the same Aragon diagram. Now we see it's preloaded with Z1. And if you kind of follow the trend here, the real part is similar to the x-axis. The imaginary part is similar to the y-axis. So it's here the -1 on the real, okay, with the 2 on the imaginary. So that's -1 plus 2i. Now in the answer, okay, Z2 is 2 plus 3i. That's 2 on the real. That's 3 on the imaginary. Then Z3 is 4 on the real part, -1 on the imaginary. 4 minus I. And that's it. Okay. So moving on then to part 2, it says work out the modulus of Z1. Now the modulus is another way of describing the distance of the complex number from the origin. Now if I was to go back, we're looking for this distance here. Okay. Now, some people might choose to do this and make a right angle triangle, use Pythagoras, okay, in order to find that hypotenuse, which will be the answer. But there's a kind of derivative of the modulus formula, and we look at that in a second. But a complex number can be described as the real part, and we're going to call that A, and the imaginary part, and we're going to look at the number in front of the I there, which is +2. So my A value is -1, my B value is +2, and that's useful for the modulus formula, which is effectively Pythagoras' theorem with the square of the hypotenuse brought across. So it's this formula here. Once I input my numbers, okay, instead of the A, I'm putting -1 in brackets, so the calculator understands that's a negative number. And the B value I'm putting in brackets, and it's 2. I can run this right-hand side through the calculator. I get an answer of square root of 5. Okay. That's it. Now, the second part of the question here says, give your answer in third form. That just means leave it as a square root. Okay, leave it in square root form, not a decimal. Now, part 3 then says Z4 is a complex number where its modulus, these bars mean the distance of, in complex numbers, that means modulus. The modulus of Z4 is less than the modulus of Z1. Write down one possible value of Z4. Give your answer in the form of A plus BI, where A and B are elements of Z, and that just means they're integers. They can be either a positive or negative whole number. Not a fraction, not a decimal, they're whole numbers, but they can be positive and they can be negative. Okay. So if I then go to the answer, okay, I can in a way state this, okay, that's saying that they're less than the square root of 5. We're trying to figure out what numbers would give an answer less than a square root of 5. So there's multiple answers here, okay. In a sense, what values of A and B would give an answer less than root 5? Now, for simplicity, 1 and 1 would work. Okay. In fact, it's the only answer it can be now that I think about it. Okay. If it was 2 and 1, you still get square root of 5. If it was 1 and 2, you still get square root of 5. If it was -1, -2, you still get square root of 5. So it's 1 and 1 in order to satisfy the fact that they're whole numbers. Hope that makes sense. Okay, it's a bit tricky in the way it's written, but always be trying for the attempt. I've tested here, okay, with my new complex number. I found the modulus of it, and it is root 2. Root 2 is less than root 5, so that works. Now, part B then says U and V are two complex numbers. It gives me what u is, it's 4 minus 6i. It gives me what v is, which is 1 plus I. And then it says write u over v, which means u divided by v in the form a plus bi. And again, a and b are m to z. That means that they are integers. They can be positive and negative numbers, whole numbers. Now, the division of complex numbers is essentially we divide to divide complex numbers, we multiply top and bottom by the conjugate of the bottom. So the question then is, what's the conjugate here? Now, if you look at this infographic I threw in, the conjugate at the bottom is just the complex number with the sign changed. And not always to negative, it just depends what the complex number is. So in this situation, the complex conjugate to 1 plus I is 1 minus I. So I'm multiplying top by 1 minus I, and I'm multiplying bottom by 1 minus I. That's going to take a bit of work. You can do it off in rough work, or you can do it as part of the question. I'm writing it more formally using brackets just for my own self. I'm going to do the top here. So I'm writing out one complex number, 4 minus 6i. I'm writing it out twice. Then the first term is multiplied into the first bracket. The second term is multiplied into the second bracket. Bog standard multiplication of a two-term bracket by a two-term bracket. Now I'm doing the exact same thing on the bottom. Okay, and I'm going to then just work left to right, top, then bottom, and try simplify it down. So 1 by 4 is 4. 1 times negative 6i is negative 6i. Then minus I by 4 is minus 4i. Minus I by minus 6i, minus by minus is a plus. I by 6i is 6i squared. Just the same as x by 6x is 6x squared. Now all the way across the bottom, 1 by 1 is 1. 1 by I is I. Minus I by 1 is minus I. Minus I by plus I is minus I squared. I can do a little bit of simplification here, adding those numbers together, okay? Not unless it's changing. I'm just adding the minus 6i minus 4i. I owe you €6. I owe you €4. I now owe you €10. Exact same concept as adding x's or adding i's, adding whatever. Now on the bottom, the plus I and the minus I, they'll cancel. Plus 1, take away 1 is gone. So that's why they disappear in this answer up here. And that's as far as we can go until we remember this fact, and that is that I squared in complex numbers is the same thing as negative 1. Okay, it's most likely said at the beginning of the question. I'd have to look back to make sure. Okay, but that's a fundamental thing we need to remember in terms of complex numbers. Once I remember that, I can swap out this I squared with negative 1, and I do it in brackets. I do it here in the top, and I do it again here in the bottom. And that leads to a little bit of complexity. I have to remove those brackets. So I'll do that, okay? The 4 minus 10i doesn't change, but plus 6 times minus 1 is minus 6. And on the bottom, 1 take away negative 1 is the same thing as 1 plus 1. That leads me now to my answer. I'm going to combine the real parts here. 4 take away 6 is negative 2. And the bottom, 1 over 1 plus 1 is 2. You'd be tempted to leave your answer like that, but the 2 will divide evenly into the top part. I'll end up with minus 1. 2 into minus 2 goes minus 1 times. 2 into minus 10i goes minus 5i times. That's in the form of a plus bi. Okay, and that's the answer. Now that's the end of question 2. So if you want a copy of these notes, just send an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. And best of luck.